Okay, cool. So today we're talking about scope. And scope is something that you really want to kind of pay attention to slash be comfortable with. It's I guess like for the concepts we teach in this bootcamp, I kind of segment them into two buckets. There are like the things that like are nice to know, and there are shortcuts, and there are things that you can use to make life easier. And then there are things that are just come embedded within JavaScript, and whether you want to use it or not, like you kind of have to know it because it's always there. And so, I guess unfortunately, scope kind of falls in the latter category, in that scope is an idea that is built into JavaScript itself. And so, no matter what you write, no matter what code you write, scope will kind of always be lurking in the background. It's a very key principal concept of JavaScript. So, make sure that you kind of understand this because this really does kind of underlie a lot slash most of what we'll do in terms of kind of understanding how functions run and kind of how we create variables and kind of where we are or are not able to use variables and functions. Okay, so that sounds like a lot, but we'll try to break it down step by step. And as always, feel free to shout out any questions you may have. Okay. All right, so let's get started. So what is scope? Quite simply, scope refers to which variables can be accessed by your code based on where the code is. And so this may sound kind of simple at first, right? Which is in this idea that like, so far all we've really asked you to do is, hey, write me a function, and then everything inside the function can access everything else, right? Like in my function, if I create a variable called, let x equal 6, well, wherever else I am in the function, I am able to use x. And so far, that's kind of served us pretty well. But if we try to make the code a bit more complex, if you think about a page in which we have multiple functions, then the logic actually gets it gets a lot more complex in terms of kind of what variables can be used and where. So here, let's go through some examples, right? On line 4, if I create a variable called wow, I can obviously on line 5 just console log out wow, and there's no issue there. That works, kind of out of the box with JavaScript. JavaScript is lexically scoped, and what that basically means is it's a really fancy way of saying, sorry, let me just sorry, I'm trying to drag on the bottom. So okay, great. So JavaScript is lexically scoped, which just means that the location at which a variable is declared determines its scope. And so, more colloquially, that just means where the variable is created is where its scope is determined. Think of it like a nationality. Assuming you don't change your nationality, where you were born kind of determines your nationality to a large degree, right? So even if let's say both of your parents are American, but then when you were born in Canada, like technically speaking, you are now Canadian, right? Maybe not the best analogy, but kind of that's one way to think about it. It's just like where the variable is created is where the scope is. And so what does that look like in real life? If we look at the example here on line 6, we created a function called global. Sorry, we created a variable called global, and we set it equal to year. Then we console log out the global variable. And then on line 10, we have this function called fun function. And inside of it, we also try to console log out this global. And so when we try to run fun function, you'll see that what we do is we actually on line 8, we console log the word outer plus the word year, right? And then when we run fun function on line 14 there, we actually console log out the line on line 11, which prints out inner and then year. And so this kind of gives rise to the first or one of the main principles of this idea of scope. So scope, essentially, you can think of it as a sandbox. And variables are created within a sandbox, and it can only be used within that sandbox with some restrictions. In JavaScript, the way to know whether or not you're in a sandbox is quite simply based on the curly braces. So right now, on line 6, when we say create this variable called global, the reason we call it global is actually because if you think about the sandbox as kind of like mini like nestings or kind of these little enclosed areas, if you have an enclosed area, that must mean there's something kind of outside of it, right? And then and that area for us in JavaScript is what we call the global scope. And so when we say global scope, what we mean is that is the entire page slash that is the outermost level of the scope. So right now on the code that we have between line 6 through 14, what we actually have are two different scopes, right? Two kind of sandboxes. The first sandbox is fun function between lines 10 through 12. And we know that that's kind of that sets the beginning and the end of a scope, because we see there's an opening curly brace on line 10 and a closing curly brace on line 12. So the function itself sets a scope. Okay. And then every JavaScript file by default also comes with something called the global scope. And the global scope is basically the outermost scope that you can use. That's why on line 6, when we create this variable called global, that variable now appears on the global scope. We don't see any curly braces around there, and that's because this is a global scope. This is like the biggest sandbox we have. There's no bigger sandbox. And so in this case, one of the things that you may notice right away is, hey, even though we defined the variable global on the global scope, we are able to use it inside the scope of the fun function, right? Because on line 11, I'm printing out this variable called global, and somehow JavaScript is smart enough to know, hey, I should be looking for the variable global on the global scope. And so this gives rise to kind of one of the first kind of key ideas of scope, which is whenever a variable is being created within a scope, that variable is available within that scope and all of the other scopes that it contains. So in this case, we are creating this variable called global on the global scope, and the global scope contains this fun function scope. Therefore, anything inside this fun function can actually read from both its own scope as well as the global scope, or sometimes we call it the parent scope. So right now on line 11 there, when we're trying to console log out the global variable, what fun function is actually doing underneath the hood is the first thing it says is that it asks, hey, is there a variable within my own scope within lines 10 through 12 called global? And the answer is no, there's not. So then the next thing that this function asks is, okay, well, if I don't have a variable called global, does my parent scope have a variable called global? In this case, the parent scope for fun function is the global scope. And so within the global scope, we are now looking for a variable called global. And we see it there on line 6. And so that's the variable that we end up using on line 11. Does that kind of sort of make sense? Okay. So just note that the two big takeaways from this slide is that every piece of JavaScript is always going to have this global scope, such as this kind of outermost layer. And basically anything you put on that scope will be accessible anywhere else on the rest of the page. And then the second main takeaway is that with a scope, it basically means every time you create a variable, it means that anything in the scope in which the variable is created can use that variable, as well as any other scopes that scope contains. So here, when we create the global variable on the global scope, it means that we can also use the global variable in any of the scopes that is being created within this global scope. So let's keep moving, and hopefully, I know right now I'm saying the word scope a lot, but I promise you it will make sense once we kind of do a few more examples. And so basically this just means that when we have a global variable, it means it's a variable in the global scope, and it means it can be referenced from anywhere in our code. However, one of the things that we'll notice when we look at the way that we use this variable is you can actually think of it as kind of JavaScript going through the code twice. The first time it goes through the code, it just basically does a quick check to see, hey, what variables am I gonna create for this page? And in the second run through, it actually goes through and creates the values for those variables. And so here on line 5, we do a console.log wait for it. Then on line 7, so 2 lines later, we create this variable called wait for it, and we assign the value of here I am. And then lastly, on line 9, we console.log out wait for it again. And so when we do this, you might think the first time we hit line 5, we'll say, well, let's console.log out wait for it. Oh, wait, we haven't created it yet, so therefore it must not exist, and I would get a reference error. But rather, we see that up here, up on the upper right-hand corner of your screen, we see that we actually get undefined. And so once again, the reason for this is just because whenever, like before JavaScript even runs any code on the page, the first thing they will do is just go through and check and to make sure, hey, which variables am I going to be creating for this page? It makes a list of them, but because it doesn't assign any of those variables any values yet, it stores all of them as undefined. The second time it goes through the code, it will actually run each individual line of code and then it will assign the value. So the way that this lines 5, 7, and 9 is executing is the first time JavaScript runs through the code, it'll say console.log, okay, I'm not running it yet. Oh, on line 7, I'm going to be creating this variable called wait for it. I don't know what the value is, and I don't care just yet, but I'm going to make a note that this wait for it variable does exist, and it will be currently undefined. And then on line 9, I run some more code, but once again, this is just the first pass through. I'm not running code just yet. That's the end of the first kind of pass through. On the second time the JavaScript goes through code, it will now actually run every single operation. So the first thing it'll do is it will run console.logout, wait for it. Well, on the first pass through, we established that wait for it was temporarily going to be the value undefined. And so on line 5, when we console.logout wait for it, we get back undefined. On line 7, now we're actually assigning a value to this variable called wait for it. So we're overriding the previous value of undefined. And we assign it the value of here I am. And then lastly, on line 9, we then actually console.logout wait for it. And when we look at wait for it, the value is here I am. And so this is just like a really quick primer on kind of how JavaScript actually runs your code behind the scenes. Just make a note that it will do 2 passes. On the first passes, it will just take a look and make a list, I guess, of what variable is going to be available and stores all of them as undefined. On the second pass through, it will actually go through and execute all of your code. And so in this case, it does matter in which order you create and run code, right? If you use wait for it before we assign it, before we assign the value, like we are on line 5, then we're going to be using the value of undefined. Whereas if we use it on line 9, we're going to use the value here I am. Make sense? Cool. All right. So we've talked a little bit about the global scope, and I hinted at kind of there's another way to create a scope, right? And so this is what the other way, one of the other ways to create a scope is something called a function scope. A function scope, as the name indicates, basically is a function, right? Every time you create a function, you are creating a function scope. And so one of the really cool things about creating a function scope is anything you create inside the function can be used inside that function scope, but it cannot be used outside of the function scope. So what does that mean? So here on line 5, we create this function called happy function, right? And inside of it, we create a variable called message, I am so happy. And on line 7, we console log out the message. Notice how on line 10, we're running happy function. On line 11, we're console.logging out message. And notice how on the first time we run happy function, we console log out I am so happy. But on line 11, when we try to console log out message, we get a reference error saying, hey, there's no variable called message. And so this kind of ties in back to what we saw in the first slide, which is that for a given variable or for a given function, what JavaScript is able to do is it says, hey, I can look for this variable inside my own scope. I can look for it outside my scope onto my parent scope. I can look for the scope in its parent scope, and so on and so forth, all the way until I reach a global scope. What I cannot do is I cannot look inside anyone else's scope, right? And so right now on line 11, you'll see that we're trying to console log out the variable message. Well, in that case, what it does is say, okay, let me see if I can find it on my own scope. Is there a variable called message? And the answer is no, there's not. So then it'll say, great, let me look on my parent scope. Well, on line 11, we're already inside the global scope, so there is no parent scope to look on. And so because of that, only then do we get this reference error saying message is not defined, which basically means we've looked in our own scope, we've looked in the global scope, which in this case is our own scope. We were not able to find a variable called message, and therefore I'm going to give you back an error. We cannot look inside our child scope, or in this case, the happy function scope. One other bad analogy that I tend to use for this topic is think of it as, let's say that you are in need of some money, right? You are able to access the money in your own bank account. And if your parents or grandparents are really generous, you can also use the money inside their bank account, right? Or your grandparents' bank account. So you can look in the bank accounts of like your parents or grandparents, etc. What you cannot do is look in your kid's bank account and take money from them, or look in your sibling's bank account and take money from them, right? Same idea applies here. When I look in the scope, I can look in my own scope. I can look in the scope of my parents and my grandparents and my great-great-grandparents. I can keep looking outwards in scopes all the way until I reach the global scope. but I cannot look inside the scope of any function that is considered my sibling, so it's on the same indentation level as me, and I cannot look at any messages in my child scope. So in this case, on line 11 there, when we look for message, we cannot look inside a happy function scope because happy function is a child of the global scope. Yes? Still make sense to everyone? Okay, now let's start looking at some kind of edge cases, right? What happens if a variable is defined both globally and locally? Here we have a variable called message. We call it thing globally. On line 5, we create a function called login message. On line 6, we have a variable called message, and we say we assign to it the value act locally. And when we console log out message and login message, what we see is we get act locally. And once again, this is very consistent with if you put yourself, as a computer or as JavaScript, and think about how you run this code, right? Remember what I said. Every time JavaScript needs to look for a variable, where does it look first? Just like if you need money, where do you look first? You look in your own scope first, right? You look in your own bank account first. And so in this case, on line 9, when I need to console log out the variable message, I will look in my own scope first. What is my scope? Well, what function am I in? I'm in the login message function. So let me look for this variable called message in my login message function. And look, there it is on line 6, and the text for it is act locally. So therefore, on line 9, I will console log out act locally. However, if that message wasn't there, so here on line 6, rather than calling it message, we call it MSG. Well, on line 10 now, when I console log out message, what JavaScript's going to do is JavaScript's first going to say, well, great, let me look at my own scope again. Let me look for this variable called message. And it'll say, oh, there's no variable called message in my log message scope. And then it'll say, okay, well, let me look at my parent scope, which in this case happens to be the global scope. And is there a variable called message? Yeah, there is on line 3. And that message variable is storing the value of thing globally. And therefore, when I console log out message on line 10, I actually get back the message variable from line 3. Make sense? So JavaScript will always look in its own scope first, then it will look in its parent scope, then it will look in its own parent scope, all the way up into the global scope. So there is a very clear, distinct order in which JavaScript will look for these variables, and once it finds a match, it stops. It doesn't care if there are multiple matches in the parents or grandparents. If I find a variable in my own scope, I use that first, and I don't look at any other variables. Make sense? Awesome. This is a very quick, kind of just simple application of this. You know how sometimes when we create a function, we also pass something called parameters, right? We put into the, like in this case, on line 5 there, this function, we're log a message. We know that takes in a parameter called message, and we use that message variable inside the function. Well, the message is also confined to the scope of the function, right? So whenever you see something like line 5 there, where we're taking a parameter called message, that's basically the same as creating a variable within this log a message function scope called message. And so on line 6, when I do console.logout message, I'm going to say, great, is there a variable called message in my own scope? And the answer is, yeah, there is. It's one of your parameters. It's what's ever being passed into your function right now. And so when we look at line 9, what's being passed into our function is this string called act locally. And so when I console log out message on line 6, I console log out act locally. I don't console log out the message variable on line 3 because, once again, I have a variable called message in my own scope. By default, I will always use what's in my own scope first before I look elsewhere. All right, everyone good still? All right. We have a few more of these examples, and then, but quite honestly, this is pretty much scope in a nutshell, right? Like we've kind of covered the basic hard parts of this. So here we have an edge case now where we're not edge case. I'm sorry. Here we have a scenario in which we have multiple layers of nesting. So we have our global scope, and we create this variable called global var. We have this function called outer, and inside of it we create this variable called outer var. But within this function called outer, we actually have another function called inner. And inside this function inner, we create this variable called inner var, right? And so, this is definitely one of those slides that I feel like, take your time and look at it, especially when you have more time where you're doing the workshop to use as a template. But just know that on line 9 there, when we console log out all the variables, the global var, the outer var, and inner var. On line 9 there, when we console log out global var, we are looking for the variable global var inside the inner function first. And we're not going to find it because there's no variable called global var inside the inner function. So then we'll look inside our parent scope. In this case, our parent scope is the function outer. And we'll say, is there a variable inside the outer function called global var? And the answer is no, there's not. So then we look into its parent, which happens to be the global scope. And we'll say, great, do you have a variable called global var? And the answer is yes, we do. It's on line 2 there. And so on line 9, the global var that we use is the global var on line 2, right? Notice how we're checking each level to make sure that we don't have any other variables called global var all the way until we reach the global scope, right? If there's nothing in the global scope, then it just means it doesn't exist, period. Because once again, the global scope is kind of our like master catch-all like level or layer of scope. Similarly, on line 9 there, the outer var that we're using, it doesn't come from the inner function, because notice how within the inner function there's no variable called outer var, but in the parent of the inner function it's the outer function, and there is a variable called outer var inside the outer function, and so that's what we use. And then finally, for the last variable, the inner var variable, we say, great, is there a variable called inner var within the inner function? And the answer is yes, there is. So then we don't even check anywhere else. We'll just say, great, what is the value? And the value is inner. And so that's why when we console log out those 3 things on line 9, we get global, outer, and then inner that you see on the right-hand corner of your screen. Everyone still with me? Cool. All right. I think this is pretty much it, right? So everything from here on out is just going to be kind of examples of ways in which we use these ideas. So here, notice how we have this inner function inside, and we say like collision equals inner. On line 8, we're doing is console.log out collision. Kind of what this is testing you on is, hey, when we get to line 8 and we're console logging out collision, which collision are we using, right? Because we see multiple. We see one on line 7, we see one on line 4, we see one on line 2. So which one gets called? Well, once again, we always try to look at our own scope first, right? So on line 8, when we're trying to look for a variable called collision, we say, okay, is there a variable called collision in our own function scope, in this case the inner function? And the answer is yes, there is. It's on line 7. And then we say, great, let's use that, right? We don't check anywhere else, because it's like once we have our answer, like we don't need to look for anything else. So in this case, because of the order in which we look at, which is always our scope first, then our own parent scope, then our grandparent scope, etc., etc. Here we just say, great, we found a variable called inner in our own scope, and we're done. On the next slide, same idea. Here on line 7, we console log out collision. We'll say, great, is there a variable called collision in our own inner scope? And the answer is no, there's not. Okay, well then who's our parent scope? Well, our parent scope is this function called outer. Okay, is there a variable called collision in the outer function scope? And the answer is yes, there is. It's this parameter that we're passing into the outer function on line 4 there. Okay, great. That just means the variable collision is going to be the value of whatever is being passed into the outer function when we run it, which is happening on line 12. And if you notice, we're passing in this string called outer. And that just basically means that on line 5 there, you can think of it, imagine it. Obviously, it's not written there, but you can imagine basically us creating a new variable called collision and assigning it the value of outer. And so on line 7, when we look for the collision variable, we look in our own function scope, in the inner function scope, we don't find it. Then we look in our parent function scope and say, do you have a variable called collision? And the outer function says, yeah, I do. The value of it is outer. And so that's what ends up getting printed there on line 7. And then if we really want to drive this example home, then if we only have a variable called collision on the global scope and nowhere else, on line 7, when we try to console log out collision, we'll look at our own function scope first, which is inner, and say, yep, there's nothing there. Then we look on our parent function scope, which is the outer function, and yep, there's nothing there. And then we say, well, what's my parent's function? Well, the parent's function scope is actually just a global scope. So is there a variable called collision on the global scope? And the answer is yes, there is. Its value is global. So that's what we end up using here. Good? All right. Yep. And this is just a reiteration of kind of what we talked about earlier, which is that the inner function can access the scope of its parents. The parents cannot access the scope of either its siblings or its kids, right? So in this case, we have this function called outer on line 3. We create this outer var. On line 6, we create this inner function, right? And in it, we create this function, this variable called inner var. On line 8, when we console log out both outer var and inner var, the outer var that we use is coming from our parent scope on line 4. The inner var that we use is coming from our own scope on line 7. Ever see that? So that's pretty consistent. That makes sense what we've seen so far. On line 11, however, if you notice, we're also console logging out inner var. Well, if I put myself in the computer shoes, and when I get to line 11, what I'm basically going to ask is, oh, great, is there a variable called inner var in my outer function scope, in my own function scope? And the answer is, I don't know. Or sorry, the answer is no, there's not, right? Because I cannot look inside my child scope. Basically, everything inside the inner function is going to be a black box. And because I don't see it, it doesn't exist to me. And so therefore, I just got to say, yeah, it doesn't exist. So then when I console log out inner var on line 11, I get back this error that says inner var is not defined. The outer inner that you see printed there on the first line comes from line 8, and the error that we see comes from line 11. Good? All right, so, yep, so this is just a recap. In this case, we have multiple outer vars, and once again, we always look in our own function first. On line 9 there, when we try to look for the variable called outer var, we say, is there a variable called outer var in our own current scope? And the answer is yes, there is. It's a parameter there on line 7, right? So let's use that one. So what is that one? That is whatever is being passed into the inner function when we run it. Well, we run the inner function on line 11 there, and if you notice, we're not passing anything in. And so what is the value of a variable if we create it but we never give it a value? Well, then by default, the value of it is undefined. So that's why we see undefined there when we print it out. Right? So even if there's no real value, we still use the variable that exists in our own scope first.
Hey, I have a question.
Yep.
So what would happen if you had one function and you declared the variable in the function, but then you also passed it in as a parameter? Which one would take precedence?
That's a really, really good question, and I believe nowadays that actually you'll actually get a warning or some kind of error. So let me find this for you really quickly. One of the things I always like to do when I have a question like this is I just say, well, let's just write the code and test it out, right? There's no better way for us to figure out what actually happens. So if I understand you correctly, Alex, what you're saying is, let's say I have this function called David. I take in whatever, it doesn't matter, and then beneath it I'll run David. Okay, and then here what I'll do is you're saying is let x equal 6. Oh, let x equal 6, but we also take in a variable x here, right? And so your question is now when I console.log out x, which x is being used? It is the x on line 1 or the x on line 2, correct?
Yeah.
Great. So when I do this, I should get an error, I believe. Okay, yep, we get this error here, right? And the error is actually pretty verbose and pretty clear. I'm not sure if everyone can see it. It basically says, hey, you've already created the x variable already here. So it's actually stopping on line 2 and saying, I can't run this line of code because you're creating a variable that already exists.
Okay.
Yeah, so that won't be an issue. Now, what could happen is I could have something like this, right? And so what this is saying is, if I'm not creating a variable, then what's happening here is that I'm actually saying, you can imagine this as like kind of like shadow code that's running like let x equal 7 when we first pass it as a parameter. And then on line 3, I'm not creating another variable called x and setting it equal to 6. I'm just overwriting the current value of x to be 6. And so therefore, when I do this and I console log out x, I get back 6 because I'm basically saying, here, on this first line, x is 7. Then I set it equal to 6. So now what's the value of x? Well, the value of x is the last value that it was assigned. So in this case, it's 6.
Okay, that makes sense.
Yep. So whether or not having this let here is super important, right? This is just overwriting an existing variable. This is creating a brand new variable. Good, cool.
Yep.
Yep, awesome. Okay, so let me all right. So yep. So that's the same thing before. And then this is like the very last bit. And if you understand everything so far, then this should be also really simple. Basically, like all curly braces, more or less creates a scope now in JavaScript, including the curly braces we see for if statements, for while loops, for loops, etc. They're not called function scope because they're not functions. They're called block scope because they're blocks of code. And so here on line 4, you'll notice that we have this if statement, and in it we create this variable called block. If I try to console log out block outside of this if statement, once again I get an error, right? Because when on line 9, when I try to find the variable called block, I look at my own scope, which is a global scope. I cannot look at my child scope, which is what this if statement's scope is. And so I get an error saying, yeah, as far as I know, on the global scope, the variable called block does not exist. And so basically everything I just said for functions, it also extends to if statements, for loops, while loops, basically any process that begins and ends with a curly brace to designate a particular block of code. Make sense? Awesome. And then this is just kind of more of like a fun fact. If you ever see, so you really shouldn't be using the variable, or sorry, you really shouldn't be using like the reserved word var to create variables anymore. And the reason for that is because nowadays JavaScript uses something called let, and the difference between var and let is var basically ignores the block scope. So when you create this variable called block, it actually attaches it to the function and not to the nearest block, which in this case happens to be the if statement. This is not really important for you to memorize. Just know that going forward, you really should be using let to create all of your variables. And when you use the let keyword to create a variable, it means it is confined to the nearest set of curly braces that it finds, right? So if it's an if statement, it will be confined to the scope of the if statement. If it's a function, it will be confined to the scope of the function, etc. Cool. Yeah, so here basically because we created with var block equals Jenny from the, on line 8, when we try to print out block, on the last slide we got an error. This time it works because what var does is var basically says, oh, it's like I don't even, I don't respect or I don't recognize this scope made by the if statement. So I'll pretend like it's on there and I'll just toss it on the global scope directly. Cool. And yep. And then so the very last thing we'll talk about here is this idea of hoisting. And so hoisting is a more formal way to describe what I just said in terms of like, JavaScript making two passes on the code. The first time it passes through a code, it just makes a list of, hey, what variables exist, what doesn't. And the second time it goes through a code is when it actually runs the code. Hoisting is the word for that. And if you notice here on line 4, I am running this I'm running this function called will this work. I run it on line 4, but I really create it or define it on line 6. And the question is, does this work? Well, basically any function that you define with a function keyword, like the way you're doing on line 6, that's called a function declaration. And what that means is when JavaScript passes through this code the first time, it will say, hey, these variable exists, but this function, will this work? That function also exists. Okay, so it's making note that that function also exists. The second time it goes through this code on line 4, it will say, great, let's run will this work. Well, at that point, JavaScript has already recognized that the will this work function already exists online, or it already exists and is valid. So therefore, on line 4, we are able to run this will this work function, even though when we look at it kind of as humans, we're like, well, we're running this function before it's defined. But because JavaScript does two passes on it, on the first pass, it is already recognized, or if you can think of it as kind of hoisting, it hoists us up already, or it lifts up this function to the top of the page to recognize that, hey, this function is able to be used anywhere else on this page from this point forward. This is to contrast this with another way to create a function, which is what we call function expression. And we call it expression because, once again, it is an expression, right? Notice on line 6, we create this variable called will this work, and we assign to it the value of this function. Now, the first time JavaScript passes through this code, it will say, okay, line 4, we're running a function. I don't need to worry about that just yet. It gets to line 6 and says, okay, great. Let me create this variable called will this work. What's the value of will this work? I don't know, so it's undefined, right? The second time it runs through this code, it will say, let's execute will this work. Well, does will this work exist? Yeah, it does. I saw it on the first pass through. Great. What's the value? Well, the value is undefined. Okay. And so line 4 is asking you to run that, to execute that undefined. And so when I run this, I will get back, and well, this is actually an error, right? But when we run this, what you actually get is you'll actually get back an error saying, hey, I can't run this function because I cannot run what is technically speaking undefined. So if I paste this in, and let's just ignore these formatting quirks here, and when I run this code now, I'm going to get back an error saying is, hey, I cannot run this because will this work is undefined, it's not defined, like it's not a function, right? And once again, the difference is because when we create it with a function keyword, it's a declaration, so JavaScript recognizes it as a function on the first pass through. When we do it this way, it doesn't recognize a function, it just recognizes the will this work variable exists, period. And so in that case, we actually can't execute it because we don't know what the value is yet. Cool. So that's all this stuff. One good rule of thumb to note is that one of the dangers of using one of the dangers of using a global variable is that, hey, we actually don't know who's kind of touching it or who's changing it, right? So if you notice here on line 2, we have this always true variable. We assign the value of true. On line 4, we have this don't mind me function, which we run on line 8. And what that does is it changes always true from true to false. On line 10 now, if I use always true, by the time I get to line 10, if I look at line 2, I'll say, well, this is a variable called always true, and it's set equal to true, so therefore I should be able to use it. However, by the time I get to line 10, the danger here is that because everyone has access to this always true variable, you don't really know if anyone else has changed it. And so therefore, it's hard for you to kind of use that variable with absolute certainty to say, hey, this value is this, right? And so that's kind of the reason for scope and for scope existing in the first place, right? It's this idea that like, hey, certain things should be sandboxed, right? Like certain variables should only exist in places where the right person or the right function or the right, block scope can use it. It's the same reason why, you don't give out your credit card information to everyone, right? It's like, well, yes, this information exists, but only certain people need to know how to need to know when or need to know it, right? What the value is, and only those people should be allowed to change it. It's the same way that the employees of a bank may know the access to the safe, right? But they don't go around telling everybody because not everyone is supposed to know it. Same idea here. When you have a variable on the global scope, because anyone can change it, using it is always kind of a crapshoot. Like you're always not sure if anyone else has changed it before you use it. Then does that make sense conceptually? Okay, great. And then very lastly, one of the ways to get around this is, hey, rather than changing the global variable, just make your own variable, right? Here on line 5, rather than changing the global variable, we just create our own variable called always true. And now whenever we use it within the don't mind me function, we're going to use it based on the value that we've assigned to it, right? But because we're creating a new variable called always true in another scope, we actually never change the always true on the global scope on line 2. So therefore on line 10, we can actually pretty confidently say that that is still true, right? So basically the short of it is, use global scope very sparingly. If you're using a variable on a global scope, just be cautious that other people may have already changed it. And then if you do want to use something that that happens to be named the same thing as something on the global scope, just create your own version of it. Is like the shortest way to make sure that that you're working with a clean value. And then Oh, and then sorry, and then this, like the short version of this is also just avoid using global variables as much as you can, right? You have these variables that you create that are really kind of unsafe, and you don't want other people to override it, and other people may want to name it the same thing as you. And so because of that, as a best practice, is just use as few global variable scopes as possible. All of your scopes, or sorry, all of your variables should have either a function or a block in which it's being created and being used. So create it there, use it there, right? Once you leave it, unless like that variable should no longer exist, even if you want to pass a value out, you can still do that. But that variable theoretically, should only be used within the confines, right? So if you think of each function or each block scope as like a factory, like you can think of like the variables as like the machinery, right? Like you can use the variables to generate whatever product you want, and you can use that product after you leave the factory, but you really shouldn't be shipping that machinery along with the product. So yeah, so minimize use of things on a global scope. And that is pretty much it. So any questions? Okay. All right. Well, if there are no questions, then I will stop the recording, and then I will also oh, sorry. If there are no questions, I will stop the recording, and then I will send you on your way to start working on the workshop.